So the previous question or the previous lesson was if you want to start from now depositing and saving money every month, you want to deposit into the account. So after so many years, you can go to the bank and say, there is a big lump sum of so much dollars, right? Now the question is, what if you want to have a regular payment? Let's say you want to have a regular payment that you want to take out every single month from your account, and you want that regular payment to last you for 10 years. Okay? How much money should you deposit in the account today, right, in order to be able to get that regular payment for the next 10 years? So the question is different. How much should you deposit right now? So what is your present value right now that you should put in order for you to be able to have that security of regular withdrawal that you can make in the future? Okay? The previous question was, what would be your amount in the future? Okay? This would be how much you should invest right now. So there is difference in the wording, and you should be able to identify between the two. Okay? So again, we're still doing regular deposit or regular withdrawal. Okay? So we still have that letter R, right, which means the regular deposit or regular withdrawal. And then the rest are still the same, I at the end. And then the PV is your present value. Okay? PV is the same thing as if you want your just the P, right? We've seen it before, but in a different form. So P is your present value. Or the amount needed today. R is the regular payment or deposit. I is still I, R divided by N. And it is the interest rate. And N is your period, compounded period. And then remember that N has to be in the same unit, so if it's not, then you have to do the years times the compound period. So when you're reading the question, you need to be looking for the keywords, okay? Are you looking for the amount in the future, or are you looking for the amount now? Okay? So let's look at Victor wants to withdraw $700 at the end of each month for 8 months, starting 1 month from now. His bank account earns 5.4% per year compounded monthly. How much must Victor deposit in his account today to pay for the withdrawals? So he wants to take out every month, he wants to take out $700. Right? But the bank, if he deposits money right now in the bank, right, The bank is gonna give him 5.4% compounded monthly. Okay? How much he should deposit today in order to be able to withdraw that $700?
So $700 each month or
Each month.
for 8 months?
Each month for 8 months.
Okay, so now we should multiply by 8.
Should multiply what by 8?
700.
But remember that I want to know how much money. If you do 700 times 8, this is how much money he's gonna take out in total,
Okay.
right? This is how much money he's gonna take out in total. Does he have to deposit all of this money into the account? No, because the bank is gonna give him some money. So why would he do that? Okay. So let's calculate how much. What's that? What's 700 times 8?
5,600.
Okay, so this is how much he's gonna take out, right? Instead of like using the 5,600, he can actually deposit less amount of money because the bank is gonna give him percentage, right? So if you go to the bank right now and say, here's my money, they're gonna have to give you a percent on this money, right? Interest percent. And that interest percent is gonna help to pay off that $700 a month, okay? So let's look at the formula. So I know that I have to find the present value because this is what the question is asking. Okay? How much he needs to deposit today. So that's the present value. I need to look for that. What's my regular payment? What my regular withdrawal? 700. What's up?
It's
5.4%, 0.054.
By 12. Because it's compounded monthly.
Monthly.
Okay? Now what's N?
8 times 12.
Now be careful.
Oh.
8 is already 8 months. It's not 8 years.
Oh yeah. So
And that's why I don't need to multiply that.
That's true.
Remember I told you, you have to make sure that your N, if it's in the same unit, you don't need to change it. It's 8.
It's per year.
Oh.
It's 8 months.
Oh, okay.
It's not 8 years.
Okay, got it.
Right? If it's 8 years, then you have to multiply by 12.
Mm-hmm.
Right? But because it's already in month, I don't need to change it.
That's why times N, right? Okay. Got it.
Now, can you guys tell me what's 0.054 divided by 12? Is that a very weird number?
0.004.
54 divided by 12. Sometimes if your number when you divide is very big number, you probably want to put the whole fraction in, or you have to put the whole side, right? Or you have to put the whole decimal in, okay? Otherwise your number is going to be different. It makes, if your amount is big, then it's going to make a big difference, like thousands of dollars difference. Okay? So what I'm saying is, if when you divide this by this, guys, if you divide this by this, and you have like lots of decimals, you either want to include this whole thing as a division in your formula, or you want to include the whole all of the decimals, because otherwise if you don't do that, it's going to make a difference in the money that you're going to have at the end.
Okay.
Okay? And if the thing is long time or big money, it might be a difference of thousands of dollars. Okay, so the formula is, what is the formula? You guys have to stop.
PV equal
PV
R,
equal to R.
open bracket, 1 minus, open bracket, 1 plus I, close bracket, negative N.
To the power of negative N.
Divided by
Yeah,
I.
the power of negative n. So you have to be careful when you're plugging in your formula that you're plugging into the power of negative n. Okay?
That one.
So let's fill in this. I don't know why this is acting up today. what you guys are gonna get. What did you get?
5,488.
Yeah.
Yep. That's negative number, right?
Yeah.
Yes, so 5,488. Now, how much money is he gonna actually withdraw altogether? He's gonna withdraw 5,600, right?
Right.
But he only has to deposit 5,488, and the rest is going to be interest that the bank is gonna give him.
Right.
So yes, it's not a lot of interest that the bank is giving him, but remember, it's only a short-term
So I want-
deposit, right?
But I get negative number.
What do you get?
No, negative 5.488.
You're probably doing something wrong right here. We're probably not putting to the box -8. That could be it.
I'm gonna do it again.
Yeah.
You get the same thing?
$5,000.
Really?
Yeah. We get negative.
You get negative.
Yeah, negative. Simple as it. Easily.
There's a negative next to it.
So,
You're gonna get that.
are you guys getting that answer?
So what's that? 1
Plug the whole thing together, it was even different.
Yeah.
Right? Oh my
So you're
gosh.
gonna do this, 1
Yo.
minus, open bracket.
When I plug the whole thing, it gives me the
That's
same
the power, and
answer.
then put 8 minus.
That is possible,
Yeah.
right?
When I put the whole formula,
Yeah.
it gives me the same answer. Without no.
You don't have, yeah. Your calculator is pretty good, so you can do that.
Get it right again.
Okay. How much interest did the annuity earn? So how much interest did he earn?
How much interest?
multiply
Oh.
Oh, I
by 8.
Yeah.
So what's the R?
Subtract that number from
That's right.
Yeah.
7 multiplied by
So-
8.
So first one is.
Sure.
Yeah, this is how much he withdrew, right? To find the interest, you do 5,600 minus how much he deposited,